Okay, hey guys, this is Melina. This week's video is going to be an introduction to conjugated systems. So first off, what is a conjugated system? So conjugated systems have at least 3 p-orbitals, and within that system, they will have a vinylic and allylic position. So if I were to draw a structure that looked like this, and right there, the vinylic carbons are the ones involved in the double bonds. So that would be carbon, if I were to number these, let's number these in pink. 1, 2, 3, 4. And highlight the vinylic carbons. Those would be carbon 3 and carbon 4. On the other hand, there are allylic carbons, which are adjacent to the double bond, and so they're 1 carbon away from the double bond. And that would be, in this structure, it would be carbon 2. Allylic positions are also resonance stabilized. So if I were to draw a structure that looked like this, oh no, let's erase that. If I were to draw a structure that looked like this, like that, and there was a lone pair at the end, as you can see, 1, 2, 3, 4, 5. Carbon 5 in this structure is the allylic position, and you can draw resonance to form this structure. 1, 2, 3, 4, 5. The double bond will be there. The lone pair is now here. The carbon number 5 is stabilized by resonance. Next, we learned the concept of dienes. What dienes are a structure that has 2 alkenes within the same molecule. So as you can see, what I provided right here are just a bunch of different structures with 2 double bonds in the structure. Right now, we're not concerned with where they are, but if there's at least 2, or if there are 2 double bonds in the structure, then it is considered a diene. So in the first structure, that's 1, 2, 1, 2, 1, 2, 1, 2. These are a bunch of different dienes. So now we're going to go into the types of dienes that we have. The first one we have is an isolated diene. And with an isolated diene, the double bonds are separated by at least 1 carbon. And I'm really emphasizing at least. It doesn't have to just be isolated. They don't have to be separated by just 1, but if there's at least 1 carbon that's separating the double bonds, then it is an isolated diene. And because the double bonds are separated by at least 1 carbon, the double bonds are too far apart for you guys to do resonance. So for example, if I were to draw a structure that looked like this, and then let's label our carbons. 1, 2, 3, 4, 5, 6. As you can see, the double bonds are occurring between carbons 1 and 2 and 5 and 6. But carbons 3 and 4 are separating those double bonds, so it is an isolated diene. Next, we have a cumulated diene, and that is when the double bonds are connected to the same carbon. So if I were to draw a structure that looked like this, and let's label our carbons. 1, 2, 3, 4, 5, 6, 7. The double bond is occurring at 3 and 4, and again from 4 to 5. And as you can see, carbon number 4 is the carbon that's shared between the 2 double bonds. So therefore, it is a cumulated diene. And if you notice, I drew the double bonds in a linear structure. The bond has a 180-degree bond angle due to how the p-orbitals are organized. And lastly, we have a conjugated diene. This is one I think you guys will be really familiar with. This type of diene you guys usually see when you do resonance problems. So the pattern I like to remember when looking for conjugated dienes is double bond, single bond, double bond. So for example, if I were to draw a structure that looked like 1, 2, 3, 4, 5, 6, like this, and let's label 1, 2, 3, 4, 5, 6. So the double bond is occurring at 2 and 3 and 4 and 5. So if you look, this is double bond, single bond, double bond. So this is a conjugated diene. Remember, just because you can rotate around single bonds, sometimes it won't look like perfectly in a zigzag type of pattern. So for example, if I drew something that looked like this, yeah, if I drew something that looked like this also has the same pattern, double bond, single bond, double bond. If I drew something that looked like, if I look like this also has a conjugated diene, double bond, single bond, double bond. So yeah, just look for those patterns. And in these structures, all of the p orbitals do overlap. Yeah, that's pretty much all you guys have learned so far. And this is just a meme I've seen. I thought it was really funny after I learned about what dienes are. So yeah, you know, before the OChem exam and then after the OChem exam, you're dying. It's not to discourage you. It's just really funny once you get to understand it. So yeah, guys, thanks for watching.